The Empress Leopoldina was a bride, sailing across the unforgiving ocean to a new land, a new life. But she was not alone. Behind her, a team of scientists, painters, and naturalists followed. Instruments at the ready, eyes keen for discovery. What they found in the emerald heart of Brazil would rewrite entire books of knowledge, and some of their discoveries remain baffling even today. Another voyage, decades later, sent an Austrian warship, the SMS Novara, around the globe. This was no mere military exercise. It was a quest for understanding, for mapping the unknown currents of the sea and the unseen pathways of trade. Yet, amidst the grand plans, a seemingly minor plant specimen collected in a distant land would one day touch countless lives in ways the explorers could never have dreamed. Further north, in the frozen waste of the Arctic, two brave men launched a ship into the ice, seeking a fabled passage. They found no shortcut, but what they stumbled upon instead was an entire new world of land and ice. A place where survival itself was a daily battle, and the very ground beneath their feet held secrets from a forgotten time. Then, from the deep blue waters of the Red Sea and the Mediterranean, another Austrian vessel, the SMS Pola, began to dredge the very bottom of the ocean. Scientists on board expected little life in the crushing darkness and cold. Their findings shattered conventional wisdom, revealing a hidden realm teeming with creatures stranger than any fantasy, defying all logic. Finally, far inland, in the scorching heat of East Africa, an Austrian explorer navigated treacherous lands, encountering powerful Navary tribes and mapping vast territories. His mission was to chart the land and its people, but the insights he gained into the intricate lives of these communities and the unexpected landscapes he unveiled offered a perspective few had ever dared to imagine. These are the stories of 5 Habsburg scientific expeditions, journeys into the unknown that brought back not just specimens and maps, but surprising findings that changed how the world was understood. Number 5. The Oscar Bowman East African Expedition. The late 1880s saw a growing European interest in the vast unmapped territories of East Africa. Austria-Hungary, seeking its own foothold in the scramble for colonies, sent explorers to chart the land and assess its resources. Oscar Bowman, a young and ambitious geographer, became one of its most determined agents. His initial forays into the region were challenging, marked by disease, difficult terrain, and encounters with powerful local communities. However, it was his 1891 to 1892 expedition into the heartland of the Maasai people that truly pushed the boundaries of exploration and yielded an array of surprising discoveries. Bowman's journey began with the familiar struggle of organizing a caravan. Porters, askaris, and translators were essential, but their loyalty and endurance were constantly tested by the harsh realities of the African interior. The expedition set out from the coast, heading west into the elevated plateaus and volcanic highlands that define much of present-day Tanka. Bowman's primary goal was to create detailed maps of this largely uncharted region, identifying rivers, lakes, and mountain ranges. He also intended to document the geology, flora, and fauna, and to record information about the indigenous peoples he encountered. The journey was a constant battle against the elements: scorching sun, torrential rains, and the ever-present threat of malaria and dysentery. Many of his porters fell ill, and the expedition often had to halt to allow recovery or to find new recruits. The oppressive heat made every step a labor. Water was often scarce, and the vast open plains offered little shelter. As Bowman pushed further inland, he entered the territories of the Maasai, a pastoralist people renowned for their martial prowess and distinctive culture. European accounts of the Maasai at the time often painted a picture of ferocious, uncompromising warriors. Bowman's detailed observations, recorded in his comprehensive work, Durch Maasai Land, Der Nieuwkwel, Through Maasai Land to the Nile Source, published in 1894, offered a more complex picture. He described a highly organized society with a sophisticated aid-grade system, intricate legal structures, and a deep spiritual connection to their cattle. His notes detailed their distinctive attire, their elaborate rituals, and their surprising hospitality once trust was established. He witnessed their council meetings where elders debated issues with a profound sense of justice and tradition. These observations presented a community far from the simplistic portrayals common in European narratives. One of the most significant geographical discoveries of Ballman's expedition was the extensive mapping of Lake Ayasi, a large, shallow, and saline lake located southwest of the Ngorongoro crater. While some local knowledge of the lake existed, Ballman was the first European to survey it in detail, charting its dimensions and noting its unique ecological characteristics. He observed the presence of large flamingo populations and other bird life, indicating a rich aquatic ecosystem despite the lake's high salinity. His mapping efforts also included the identification and precise location of numerous volcanic peaks and craters, revealing a complex geological landscape that had largely remained hidden from European cartographers. These new geographical features drastically altered existing maps of the region, filling in large blank spaces with accurate detail. The scale of the unmapped territory that still existed in Central Africa was made plain by these discoveries. The natural history collections from the expedition were also extensive. Ballman and his team collected numerous plant specimens, carefully preserving them for later study in Vienna. Among these were various acacia species, medicinal plants used by local communities, and unique grasses found in the different ecological zones. He traversed from the arid plains to the wetter highlands. Animal specimens included insects, reptiles, and birds, some of which were unknown to European science. His observations on the behavior of large mammals such as elephants, giraffes, and various antelope species provided valuable insights into their habitats and interactions within the diverse ecosystems. The sheer abundance of life in some areas, contrasted with the sparse, arid regions, highlighted the dramatic ecological variations of East Africa. A particularly striking observation concerned the intricate knowledge of the local environment possessed by the indigenous guides and trackers who accompanied Ballman. Their ability to navigate trackless wilderness, find water in seemingly barren landscapes, and identify useful plants and dangerous animals was astonishing. Ballman noted that these local experts possessed a detailed understanding of the landscape, its resources, and its inhabitants that far surpassed the scientific methods of the European explorers. Their traditional methods of wayfinding, based on an intimate knowledge of stars, terrain, and weather patterns, often proved more effective than European compasses and chronometers. In the challenging environment, this reliance on and acknowledgement of indigenous knowledge was a subtle but important finding. Ballman also documented the presence of distinct linguistic groups and cultural practices that were previously unrecorded in Europe. His detailed descriptions of the Iroquois people, for example, their unique agricultural practices, and their distinct housing styles, provided new data points for ethnographers. He noted the complex trade networks that existed between different communities, indicating a level of economic interaction and interdependence that challenged simplified notions of isolated tribal existence. The sheer variety of human cultures encountered in a relatively confined geographical area was significant. Each community had its own unique way of life, its own set of beliefs, and its own methods for survival in their specific environment. The challenges of transporting fragile specimens back to Europe were immense. Many botanical samples molded in the humid coastal air before they could be properly dried. Delicate insect specimens were often crushed or damaged during the long journey on the backs of porters. Despite these losses, the surviving collections represented a substantial addition to the Imperial Natural History Museum in Vienna. The maps Ballman produced were exceptionally detailed for their time, providing vital information for subsequent expeditions and for the establishment of administrative boundaries. The unexpected geographical features he charted, such as the vastness of Lake Ayasi, demonstrated how much of the world remained truly unexplored. Ballman's expedition, while rooted in imperial ambition, yielded a treasure trove of scientific data. It provided maps of areas previously marked as blank catalog species new to European science and, perhaps most importantly, offered a nuanced view of the complex and highly organized societies living in East Africa. The sheer depth of indigenous knowledge about their environment, the intricate social structures observed, and the vast scale of unmapped natural features stood as surprising results from Oscar Bauman's determined exploration. Number 4. The Polar Deep Sea Expeditions. In the late 19th century, the deep ocean remained one of Earth's greatest mysteries. Scientific theories, such as the Azoic theory, proposed that life could not exist below a certain depth due to the crushing pressure, extreme cold, and absence of light. Yet a growing curiosity about the hidden depths spurred nations to explore. Austria-Hungary, with its burgeoning navy and scientific community, was no exception. Under the initiative of Captain Franz von Marbach, Rheinberg, the SMS Pola, a survey vessel of the Austro-Hungarian Navy, embarked on a series of ambitious deep-sea expeditions. Beginning in the early 1890s, their primary focus was the Red Sea and the eastern Mediterranean regions with significant strategic importance, and, as it turned out, surprising biological and oceanographic secrets. The Pola expeditions, which spanned several years and multiple voyages, were equipped with the latest deep-sea dredging and sounding technology available at the time. This equipment, while cutting-edge, was often temperamental. Winches designed to lower and retrieve miles of cable supporting heavy dredges and thermometers frequently jammed or broke. The sheer weight of the cable and the equipment at extreme depths put immense strain on the ship's machinery and the crew. Scientists from the Imperial Natural History Museum and the University of Vienna were on board, meticulously recording data and handling the delicate specimens retrieved from the abyssal plain. They faced long hours on deck, often in harsh weather, as they waited for the dredges to surface, sometimes for many hours. One of the most striking and immediate results of the Pola expeditions was the abundance of life found at depth previously thought to be barren. The Azoic theory, which held that life disappeared beyond a depth of roughly 550 meters, 1,800 feet, was comprehensively disproved by the Pola's findings. Dredges brought up a bewildering array of marine organisms from depths exceeding 1,000, 2,000, and even 4,000 meters. 13,000 feet. They discovered fish with unusually large eyes, or no eyes at all. Some with bioluminescent organs that pulsed with eerie light in the darkness. Invertebrates of bizarre forms, including alien-like crustaceans, gelatinous jellyfish, and strange-looking sea cucumbers, populated the deep-sea samples. Many of these creatures exhibited unique adaptations to their extreme environment, such as elongated limbs, specialized feeding apparatuses, or the ability to withstand immense pressure. The sheer diversity of species living in such harsh conditions was a profound revelation. Beyond the biological discoveries, the Pola expeditions collected an unprecedented amount of oceanographic data. They meticulously measured water temperatures, salinity levels, and oxygen concentrations at various depths across vast stretches of the Red Sea and Eastern Mediterranean. These measurements revealed complex underwater currents and distinct water masses that were previously unknown. For example, they found that the Red Sea, despite its connection to the Indian Ocean, had unique thermal and saline characteristics that created a distinct environment. The discovery of layers of water with vastly different properties, sometimes sharply demarcated, demonstrated the intricate stratification of the ocean and the forces that drive these invisible boundaries. These detailed profiles provided a foundational understanding of the physical oceanography of these important bodies of water. The mapping of submarine topography was another critical aspect of the Pola's work. The sounding lines, often stretching for miles, helped to chart the contours of the ocean floor, revealing hidden trenches, submarine ridges, and vast abyssal plains. For instance, the expeditions contributed significantly to understanding the bathymetry of the Hellenic Trench in the eastern Mediterranean. One of the deepest points in the Mediterranean Sea, the intricate and varied landscape of the seabed with its mountains, valleys, and chasms was revealed in surprising detail. Before these surveys, maps of the ocean floor were largely speculative, often showing vast undifferentiated plains. The Pola's soundings painted a much more complex and geologically active picture. One surprising observation related to the distribution of specific species. Certain types of deep-sea sponges and corals were found in areas where they were not expected to thrive, sometimes clinging to steep underwater slopes or surviving in oxygen-depleted zones. This indicated a remarkable resilience and adaptability among deep-sea organisms, pushing the boundaries of what scientists thought was possible for life to endure. Some species were found to be remarkably widespread across different basins, suggesting global deep-sea dispersal mechanisms, while others appeared highly localized, pointing to isolated evolutionary chains. The process of preserving and cataloging the thousands of specimens brought back by the Pola was a massive undertaking for the scientists in Vienna. Many of the deep-sea creatures, being highly adapted to pressure, often suffered damage or even disintegrated as they were brought to the surface. Delicate organisms such as gelatinous siphonophores required immediate and careful preservation in large fats of alcohol. The sheer volume of material meant that its full study would take decades, resulting in numerous scientific publications detailing the new species and the oceanographic findings. The collection continues to be a vital resource for marine biologists today. The Polar Deep Sea expeditions provided undeniable proof that life thrived in the deep ocean, challenging long-held scientific beliefs. They revealed a hidden world of diverse creatures with astonishing adaptations, mapped the complex and varied contours of the seabed, and provided a detailed understanding of the physical properties of vast ocean basins. The sheer abundance of the unexpected life discovered beneath the waves was a profound and surprising result that reshaped humanity's understanding of the planet's largest habitat. Number 3. The Tegetthoff Arctic Expedition. In the mid-19th century, the Arctic remained a vast, largely unknown wilderness, a tantalizing blank space on world maps. The fabled Northeast Passage, a sea route connecting Europe to Asia across the top of the world, beckoned explorers with the promise of faster trade and glory. Karl Weiricht, a determined Austro-Hungarian naval officer, and Julius Payer, an accomplished alpine climber and artist, became convinced that such a passage existed and could be navigated. Driven by private patronage with support from Emperor Franz Joseph, they launched the Austro-Hungarian North Pole expedition in 1872 aboard the specially constructed schooner, the Tegetthoff. Their mission was to find the Northeast Passage and conduct scientific observations along the way. What they found instead, and the way they found it, was an epic tale of survival and accidental discovery. The Tegetthoff sailed north, battling thick ice from the outset. The expedition was meticulously planned, with provisions for 3 years, warm clothing, and scientific instruments for meteorological, magnetic, and zoological observations. However, the Arctic environment proved far more formidable than anticipated. Just weeks after entering the Barents Sea, the Tegetthoff became trapped in the ice pack, a prisoner of the frozen ocean. The ship was frozen solid in October 1872, far from any known land. What was intended as a swift passage became an involuntary drift. The crew, already facing the intense cold and isolation of the polar night, found their ship drifting helplessly with the ice for almost 2 years. Scurvy, a debilitating disease caused by vitamin deficiency, began to affect the crew despite their provision. The mental toll of constant darkness, extreme cold, and the uncertainty of their fate was immense. For nearly a year, the Tegetthoff drifted west and north. Then on August 30, 1873, in the midst of their involuntary journey, a dramatic discovery was made. Through a break in the fog, Payer and Weiricht sighted land previously unknown to European explorers. It was a vast archipelago of islands, glaciers, and mountains. They named it Franz Joseph Land, in honor of their emperor. This discovery was completely unexpected. Their initial objective was the Northeast Passage, yet they had stumbled upon a major landmass in the high Arctic that was completely uncharted. Peyer, with his background as an artist, immediately began sketching the rugged landscape, capturing its stark beauty and the imposing ice formations. Over the next year, despite still being trapped in the ice, Peyer led several grueling sledge expeditions across the newly discovered land. These journeys were fraught with danger, involving traversing treacherous glaciers, avoiding polar bears, and enduring blizzards that dropped temperatures to unimaginable lows. During these excursions, Peyer meticulously mapped the islands, naming bays, capes, and mountains. He gathered geological samples, noting evidence of ancient forests and warmer climates in the fossilized plant remains found on certain islands. This geological evidence suggested that Franz Joseph Land, now a frozen wasteland, had once supported significant vegetation, a surprising contrast to its current desolate state. Weyprecht, meanwhile, continued his scientific work from the icebound ship. He conducted daily meteorological observations, meticulously recording temperature, wind speed, and atmospheric pressure. These continuous records provided invaluable data on the Arctic climate, revealing patterns and extremes that were previously unknown. His magnetic observations were also crucial, helping to understand the complexities of the Earth's magnetic field in the polar regions. The expedition also observed the unique Arctic flora and fauna, including polar bears, seals, and various seabirds. Their resilience in such a harsh environment was remarkable. The sheer scale of life, even in the desolation, was surprising. After nearly 2 years of being trapped with their ship still firmly held by the ice and their provisions dwindling, Weyprecht and Peyer made the audacious decision to abandon the Tegethoff in May 1874. This was a desperate gamble for survival. They loaded their remaining supplies, their scientific records, and their most valuable collections onto sledges and small boats. For 96 days, the crew undertook an arduous journey across the broken, shifting ice pack, dragging their heavy sledges, rowing their boats through leads of open water, and battling constant exhaustion and the ever-present threat of hypothermia. They faced constant dangers from cracking ice and open water, navigating a landscape that offered no solid ground. Their survival during this desperate retreat was a testament to their leadership and the resilience of the crew. They eventually reached open water and were spotted and rescued by 2 Russian sealing ships, bringing an end to their harrowing ordeal. The men had lost significant weight, suffered from frostbite, and endured immense hardship, but they had survived. The primary goal of finding the Northeast Passage was not achieved. The expedition conclusively demonstrated the extreme difficulty, if not impossibility, of navigating a continuous route through the ice-choked waters of the high Arctic at that time. However, the discovery of Franz Joseph Land, an entire archipelago previously unknown to the world, was a monumental geographical achievement. The detailed maps and scientific data collected despite the immense challenges provided a crucial foundation for future Arctic exploration and understanding. The resilience of the human spirit in the face of such extreme adversity and the scientific insights gained through sheer endurance stood as profoundly surprising results from the Tegethoff Arctic expedition. Number 2. The SMS Novara, circumnavigation. In the mid-19th century, Austria-Hungary, a landlocked empire for much of its history, sought to expand its influence and trade beyond European borders. Archduke Ferdinand Maximilian, the younger brother of Emperor Franz Joseph, envisioned a bold venture, a scientific circumnavigation of the world, the first for the Austrian Empire. The aim was ambitious: to promote Austrian trade, establish diplomatic ties, and, crucially, to gather scientific knowledge on a grand scale. The SMS Novara, a frigate of the Austro-Hungarian Navy, was refitted for the purpose, carrying a team of eminent scientists alongside its naval crew. From 1857 to 1859, the Novara embarked on a voyage that would yield an astonishing array of discoveries, some of which would have unforeseen and profound impacts on the world. The Novara's itinerary was extensive and challenging. Starting from Trieste, it sailed across the Atlantic to Rio de Janeiro, then around the Cape of Good Hope, through the Indian Ocean to the Nicobar Islands, Singapore, Java, Manila, Hong Kong, and Shanghai. From Asia, it crossed the Pacific, stopping at Sydney, Auckland, Tahiti, Valparaiso, and Cali, traversing through the Panama Isthmus. By land, as the canal did not yet exist, then back across the Atlantic to New York, Southampton, and finally home to Trieste. The scientists on board, led by geologist Ferdinand Hochstetter, zoologist Georg von Fahrenfeld, and ethnographer Karl von Schürzer, worked tirelessly throughout the journey. They endured storms, tropical diseases, and the sheer logistical complexity of collecting and preserving specimens in remote locations. One of the most immediate and tangible results of the expedition was the massive collection of natural history specimens. The scientists gathered over 2,700 zoological specimens, including mammals, birds, fish, reptiles, insects, and marine invertebrates. They also collected an astounding 2,689 species of plants, many of them new to European science, representing 1,460 different genera. These collections provided an unprecedented snapshot of global biodiversity, challenging existing classifications and revises across continents and oceans. The sheer scale and variety of life encountered, from the Amazon rainforest to the volcanic islands of New Zealand, far exceeded the expectations of scientists back in Vienna. A particularly significant and unexpected finding emerged from the Novara's stop in Peru. Among the various botanical specimens collected by the expedition's botanist, Dr. Richard von Dracht-Wartenberg, were leaves from the coca plant, Erythroxylum coca. These leaves, native to the Andes, had been used for centuries by indigenous peoples for their stimulant properties. While the collection of such a plant might seem unremarkable at the time, the subsequent analysis of these specimens in Europe led to a profoundly surprising result. In 1860, a German chemist named Albert Niemann, working with the coca leaves brought back by the Novara, successfully isolated and purified the active alkaloid within the plant. He named this new compound cocaine. The implications of this discovery, made possible by the Novara's collection, would not be fully understood for decades, but it marked a pivotal moment in pharmacology and medicine, with both beneficial and ultimately devastating consequences that the expedition members could not have foreseen. The Novara also made significant contributions to oceanography. Commodore Bernhard von Willerstorff, Orbert, the ship's commander, oversaw detailed measurements of ocean depths, temperatures, and currents at various points around the world. These measurements provided crucial data for understanding global ocean circulation patterns and for improving maritime charts. For instance, they confirmed the existence of specific currents and countercurrents that influenced global shipping routes, information vital for trade and navigation. The consistent collection of this data across different oceans helped to establish baseline measurements for the nascent field of oceanography. Ethnographic studies conducted by Karl von Schürzer were equally groundbreaking. In the Nicobar Islands, he documented the unique culture of the indigenous people who had previously had very limited contact with Europeans. His observations on their social structures, their customs, their languages, and their distinct way of life offered a detailed portrait of a society largely untouched by external influences. He collected a wide array of artifacts, from tools and weapons to clothing and ceremonial objects, which provided tangible evidence of their craftsmanship and cultural practices. These detailed accounts provided a counter-narrative to often simplistic European views of non-Western cultures. The variety of human societies encountered, each with its own complex traditions, was Truly surprising. Geological investigations, especially by Ferdinand Hochstetter in New Zealand, yielded surprising insights into the Earth's processes. Hochstetter's detailed mapping of volcanic regions and his collection of mineral samples provided crucial information on the geological formation of these remote islands. He observed the active geothermal areas and documented the distinct rock formations contributing significantly to the understanding of the Pacific Ring of Fire. His work also identified potential mineral resources which held economic implications for the Austrian Empire. The journey itself was not without its trials. The ship faced several severe storms, particularly while rounding the Cape of Good Hope, which tested the endurance of both the ship and its crew. Tropical diseases were a constant threat, and several crew members and scientists fell ill, though fortunately none perished. The challenges of preserving delicate specimens in a tropical climate far from modern refrigeration meant that many samples required immediate attention to prevent decay, a task that demanded constant vigilance. Upon its return to Trieste, the Novara's cargo included an immense volume of scientific material that took years to process and publish. The multi-volume Reise der Oprischen Fregat Novara die Erde, Voyage of the Austrian Frigate Novara Around the Earth, published over the following decades, became a monumental scientific work. The expedition, while aiming for trade and knowledge, brought back a coca plant that yielded cocaine, documented a previously unknown culture in the Nicobar Islands, and amassed an unprecedented collection of global bioturvit. These findings, often unexpected, profoundly reshaped scientific understanding and in some cases the very course of human history. Number 1. The Austrian-Brazilian expedition. In 1817, Archduchess Leopoldina of Austria embarked on a momentous journey across the Atlantic, bound for Brazil. Her marriage to Dom Pedro, heir to the Portuguese throne and soon-to-be first emperor of independent Brazil, was a strategic alliance for the Habsburg Empire. But Leopoldina was more than a royal bride. She was a keen amateur naturalist with a deep interest in science. Recognizing this and the unique opportunity to explore a vast and largely unknown continent, Emperor Francis I dispatched a large-scale scientific expedition to accompany her. This Austrian-Brazilian expedition, Johann Baptist von Spix and the botanist Carl Friedrich Philipp von Martius, would spend years traversing the sprawling Amazon basin and other regions, unearthing biological geological. The initial journey across the Atlantic was long and arduous. Upon arrival in Rio de Janeiro, the expedition established its base, but the real work began as Spix and Martius ventured inland. Their travels were incredibly demanding. They traversed dense, humid rainforests, navigated vast river systems in small canoes, and crossed arid savannas. The climate was oppressive, with high humidity and intense heat. Disease, especially malaria, and various tropical fevers, was a constant companion, and a major threat. Insects of all kinds, from biting mosquitoes to venomous spiders, were a pervasive nuisance. The logistical challenges were immense, involving the recruitment of local guides and porters, the transport of scientific equipment and fragile specimens through difficult terrain, and the constant struggle to preserve their collections in the tropical environment. Many of their initial collections suffered damage or spoilage due to the humidity and the lack of proper preservation techniques. One of the most striking and immediate results of the expedition was the sheer volume and diversity of new species discovered. Spix and Martius collected an astonishing number of botanical specimens totaling over 6,500 species, many of which were entirely new to European science. These included countless species of orchids, palms, and medicinal plants, some with vibrant colors and unusual forms that captivated the imagination. Martius, in particular, became an expert on palms, documenting their incredible variety and ecological importance. The zoological collections were equally vast, with over 3,000 insect species, 85 mammals, 350 birds, and numerous reptiles, amphibians, and fish. Among the bird discoveries was the strikingly blue Spix's macaw, a species that would later become critically endangered. The incredible biodiversity they encountered shattered European preconceptions about the uniformity of tropical ecosystem. Every river, every forest clearing seemed to yield new forms of life previously unknown. Beyond individual species, the expedition's observations provided a broader understanding of the Brazilian ecosystem. Spix and Martius meticulously documented the complex interactions between plants and animals, the formation of vast rainforests, and the unique adaptations of species to their specific niches. They were among the first to describe the distinct ecological zones of Brazil, from the coastal rainforests to the central Cerrado savannas and the vast Amazonian waterways. The sheer scale and intricate balance of these ecosystems, far exceeding anything known in Europe, was a profound and surprising revelation. Martius, with his broader scientific interests, also conducted extensive ethnographic research. He lived among various indigenous tribes, learning their languages, documenting their customs, social structures, and belief systems. His detailed observations challenged simplistic European views of primitive societies. He recorded intricate tribal laws, sophisticated agricultural practices, and complex spiritual rituals that showed a profound connection to their environment. For instance, his work on the Tucuna people provided insights into their unique social organization and use of hallucinogenic plants. The level of cultural complexity and traditional knowledge he encountered among these communities was unexpected for many European scholars, demonstrating highly organized societies with rich histories and intellectual traditions. Geological and mineralogical observations also yielded surprising findings. The expedition noted the vast mineral wealth of certain regions, including gold and diamonds, which had already drawn European attention, but whose geological context was poorly understood. They also documented the unique geological formations of the Amazon basin, including its immense floodplains, and the ancient shield areas, the sheer scale of the Amazon River system, and its tributaries, and its profound influence on the surrounding landscape and life was a subject of continuous amazement for the explorers. One of the logistical challenges that led to an unexpected reassessment concerned the preservation of specimens. The high humidity and heat meant that many insects and plants suffered decay. This led to innovations in preservation techniques, but also to instances where specimens transformed or were damaged in ways that altered their appearance or chemical composition, leading to later taxonomic confusion in Europe. The sheer difficulty of transporting large quantities of delicate scientific material over thousands of miles, often by mule or canoe, meant that a portion of the collected material did not survive the journey back to Vienna. The expedition concluded in 1820 for Spix and Martius. Though Leopoldina continued to support scientific endeavors in Brazil, for years, the colossal task of cataloging, describing, and publishing their findings occupied Spix and Martius for the remainder of their lives. Martius's monumental Flora Brasiliensis, a 40-volume work published over decades, became one of the most comprehensive botanical works ever produced. It cataloged thousands of species and contained thousands of detailed illustrations, touting the immense botanical richness of Brazil. Spix, meanwhile, worked on the zoological collections, detailing new species and their habitats. The Austrian-Brazilian expedition, driven by royal curiosity and scientific ambition, returned with a treasure trove of specimens and observations. It revealed a previously unimaginable wealth of biodiversity, documented complex, indigenous cultures, and provided a comprehensive understanding of a vast and diverse continent. The sheer scale of the new life forms discovered, the depth of the indigenous knowledge encountered, and the overwhelming ecological complexity of Brazil stood as profoundly surprising results that reshaped the scientific understanding of the natural world.